On September 5, 1977, a small spacecraft lifted off from Earth with a mission that few imagined would become one of the greatest adventures in human history. Built during an era when computers had only a fraction of today's processing power, Voyager 1 was designed to explore the giant planets of our solar system before quietly ending its mission. No one expected it to become humanity's most distant explorer. Engineers gave Voyager a relatively simple objective: fly past Jupiter and Saturn, collect scientific data, photograph these mysterious worlds, and transmit everything back to Earth before its systems eventually failed. The entire mission was expected to last only a few years. But space had a very different plan. After leaving Earth, Voyager accelerated toward the outer solar system, carrying cameras, scientific instruments, and a message from humanity itself. Month after month, the spacecraft crossed millions of kilometers, heading toward planets that had never been explored up close. Its first destination was Jupiter. Before Voyager arrived, Jupiter appeared through telescopes as a beautiful striped sphere dominated by the Great Red Spot. Scientists understood its size, but they had no idea how active and complex the giant planet truly was. Everything changed in 1979. Voyager transmitted breathtaking images that revealed enormous storms swirling through Jupiter's atmosphere. Some weather systems were larger than Earth itself, powered by winds moving at incredible speeds. The famous Great Red Spot proved to be a gigantic storm that had survived for centuries, making it one of the longest-lasting weather systems ever observed. Yet Jupiter wasn't the mission's biggest surprise. Its moons completely transformed planetary science. When Voyager examined Io, astronomers were stunned to discover towering volcanic eruptions blasting material hundreds of kilometers above the surface. It became the first active volcano ever observed beyond Earth. Until then, many scientists believed moons were frozen, lifeless worlds. Io proved that even small objects could remain geologically active if powerful gravitational forces continuously heated their interiors. The discovery changed how researchers viewed worlds throughout the solar system. Voyager also revealed Jupiter's immense magnetic environment, stretching millions of kilometers into space. Inside this invisible region, high-energy particles created one of the harshest radiation environments known around any planet. Every new measurement demonstrated that Jupiter was far more dynamic than anyone had imagined. After completing its historic encounter, Voyager continued toward Saturn. For centuries, Saturn's rings had fascinated observers, but no telescope on Earth could reveal their true complexity. When Voyager arrived in 1980, it showed that the rings were not smooth circles at all. Instead, they consisted of countless icy particles arranged into thousands of narrow ringlets, separated by gaps, waves, and intricate patterns shaped by gravity. The spacecraft also photographed Saturn's diverse family of moons. Among them was Enceladus, an icy world that seemed unusually bright and smooth. Although Voyager could not confirm what lay beneath its frozen crust, its observations hinted that this tiny moon might still be active deep inside. Years later, future missions would confirm the existence of a hidden global ocean beneath Enceladus ice, making it one of the most promising places in the search for life beyond Earth. By the time Voyager completed its exploration of Saturn, it had already exceeded every expectation. It had rewritten textbooks, revealed active worlds where none were expected, and completely transformed our understanding of the giant planets. Most spacecraft would have completed their mission at this point. Voyager 1 was only getting started. Instead of turning back toward Earth, it continued forward into the darkness beyond the planets, beginning a journey that would eventually carry it farther than any human-made object had ever traveled. Ahead lay the edge of the Sun's influence, and beyond that, the unknown. With Saturn fading into the distance, Voyager 1 entered a region no spacecraft had ever explored before. The familiar planets were now behind it, and ahead stretched an endless ocean of darkness. Every kilometer carried the probe farther from the Sun and deeper into territory that existed only in scientific theories. For decades, Voyager continued this silent journey, powered only by its momentum and a slowly weakening nuclear generator. It had no destination beyond exploration itself. Yet every signal it transmitted revealed something new about the unseen frontier surrounding our solar system. Scientists were especially interested in one invisible boundary known as the heliopause. This marks the point where the Sun's solar wind loses its strength and the pressure of interstellar space begins to dominate. For years, researchers debated exactly where this frontier existed and what conditions might be found beyond it. Then, in 2012, Voyager 1 crossed that invisible line. Its instruments immediately detected dramatic changes. Particles streaming outward from the Sun rapidly decreased, while high-energy cosmic rays arriving from deep within the Milky Way became much more intense. The surrounding magnetic environment also changed, confirming that Voyager had entered interstellar space. It became the first human-made object to travel beyond the protective bubble created by our Sun. The discoveries that followed surprised scientists around the world. Instead of finding an empty void, Voyager detected a surprisingly active environment. The space between stars contains extremely thin clouds of plasma, invisible magnetic fields, and energetic particles moving across enormous distances. Occasionally, the spacecraft measured faint plasma waves passing through this rarefied gas. Researchers believe many of these waves were triggered by distant supernova explosions whose shockwaves continued traveling across the galaxy years after the original stars had disappeared. These observations revealed that even the darkest regions of space are filled with motion, energy, and structure. Keeping Voyager alive has become one of NASA's greatest engineering achievements. Its radioisotope power system slowly produces less electricity each year. To extend the mission, engineers have carefully switched off heaters and scientific instruments, preserving only the equipment considered most valuable. Every watt of power now matters. Communication has also become an extraordinary challenge. A radio message sent from Earth takes more than 22 hours to reach Voyager. Another 22 hours are required before a response arrives, meaning a simple exchange can take nearly 2 full days. Despite this enormous distance, the spacecraft continues to answer. Attached to Voyager's side is one of humanity's most meaningful creations, the Golden Record. This gold-plated disc contains greetings in many languages, music from different cultures, sounds of nature, photographs of Earth, and messages representing human civilization. It was never intended as a conversation with extraterrestrials, but as a time capsule preserving who we were at the moment we first reached for the stars. Long after its electronics finally fall silent, Voyager itself will continue its voyage. It will orbit the center of the Milky Way for millions of years, passing through the darkness between distant stars as a tiny ambassador from a small blue planet. Its scientific mission has already transformed our understanding of the solar system, but its greatest legacy may be something even larger. Voyager 1 reminds us that exploration is part of human nature. It proves that curiosity can travel farther than anyone expects, carrying our questions into places no human will see for generations. Even now, billions of kilometers from home, the spacecraft continues its lonely journey, quietly expanding humanity's knowledge with every faint signal that reaches Earth. Its adventure is still unfolding, and somewhere in the vastness of interstellar space, Voyager continues moving forward, one silent kilometer at a time.